Myself, Mr. A.N., A.N., Assistant Professor, Mechanical Engineering Department. Today, we will discuss about the types of joints in a chain. Learning outcome of this session is at the end of the session, student will be able to determine the nature of chain. So, the type of joints in a kinematic chains are as follows. The first one is binary joints. Second, ternary joints. And third, quaternary joints. So, based upon these types of joints, we can determine the nature of chain, whether it is a completely constrained chain or it is unconstrained chain. So, first of all, we will see what is meant by binary joint. So, when the two links are connected at the same connection, that joint is called as a binary joint. So, we will see through the diagram. So, there are four links which are connected with each other at point A, B, C and D. So, according to the definition of binary joint, when the two links are connected together at the same connection, then it is called as a binary joint. So, link 1, link 2, link 3. So, at point A, link 1 and link 2 are connected together. So, at A, B, C and D, the binary joints are formed. Now, depending upon the type of joint, we can determine the nature of chain. The generalized relation for determining the nature of chain is J plus H by 2 is equal to 3 by 2 into L minus 2, where J is equal to number of binary joints. H, number of higher pairs. L, number of links. So, by using this generalized equation, we can determine the nature of chain. If number of higher pair in a chain is equal to 0, then this particular relation is reduced to J is equal to 3 by 2 into L minus 2. So, by using this equation, we can determine the nature of a chain. So, as this chain consists of 4 links, L is equal to 4, number of binary joints at A, at B and at C and D, there are binary joints. So, number of binary joints equal to 4, and therefore, all these pairs are lower pair, and therefore, higher pair H is equal to 0. So, by putting these values in above equation, J equal to 4 is equal to 3 by 2 into 4 minus 2. Therefore, 4 is equal to this 6 minus 2 equal to 4, and therefore, in this case LHS is equal to RHS, and from this equation we can say this particular chain consisting of 4 links is a kinematic chain, or it is completely constraint chain. Now, second type of joint is ternary joint. So, a ternary joint is one when three links are connected at the same connection, that is called as ternary joint. So, let us see the ternary joint through this figure. Now, six links are connected together to form a chain. These are connected together at point A, B, C, D. So, link 1, link 2, link 3, 4, 5 and 6. Now, in this case, according to the definition of ternary joint, when three links are connected together at the same connection, it is called as a ternary joint. Now, by observing the figure, at point A, at point E and at point C, this point A, E and C forms a binary joint where the two links are connected at the same connection. Therefore, number of binary joints at A, E and C. So, number of binary joints are 3. Now, if you see at point B and at point D, at point B, link 2, link 6 and link 3 is connected. Similarly, at point D, link number 5, 6, 4 is connected. And therefore, number of ternary joints that is at point B and D, that is equal to 2. But one ternary joint is equivalent to two binary joints, and therefore, in this particular chain, total number of binary joints is equal to 3 plus 2 into 2, that is equal to 7. And therefore, by using the relation J is equal to 3 by 2 into L minus 2 and putting the values, number of joints, binary joints are 7, 3 by 2 into number of links 6 minus 2, which is equal to 7 is equal to 7. Also, in this case, LHS is equal to RHS, and therefore, a chain consists of 6 links is also a constraint chain, or it is also a kinematic chain. Now, we will see one more example, that is the third type of joint is quaternary joint. So, when the 4 links are connected at the same connection, it is called as a quaternary joint, and one quaternary joint is equivalent to 3 binary joints. Therefore, we will see the connection of various links in this particular diagram. The various links are connected at point A, B, C, D, E, F, so in this case the number of links are 11. Now, in this particular chain consists of 11 links. At point D, there is only one binary joint. So, number of binary joint at point T is equal to 1. If you see at point C and at point G, at point C link 2, 3, 9 and 10. 4 links are connected at the same connection, that is at point C, and similarly at point G 4 links are connected, that is 11, 10, 8 and 7. So, number of quaternary joints, that is at point C and G, these are equal to 2. Number of ternary joints. So, according to the definition of ternary joint, 3 links are connected at the same connection. So, at point A, 3 links are connected, that is 11, 3 and 1. So, it forms a one ternary joint. Similarly, at point B, the link 1, 2 and 4 are connected. So, it will form another ternary joint. Then at point E, link 5, link 7 and link 6 are connected. So, it will form another ternary joint, and similarly at point F, link number 6, 8 and 9. So, there are total 4 ternary joints. Now, from this we will calculate total number of binary joints. So, 1 binary plus 2 quaternary. Now, quaternary joint is equivalent to 3 binary joints. So, 2 into 3 plus there are 4 ternary. 1 ternary joint is equivalent to 2 binary joints. Therefore, total number of binary joints will be 1 plus 6 plus 8, that is 15 number of binary joints. Then J is equal to 3 by 2 into L minus 2. So, 15 is equal to 3 by 2 into 11 minus 2, which is 15 is equal to 14.5. In this case, LHS is greater than RHS, and therefore a chain consists of 11 links is not a kinematic chain or constraint chain. The material is referred from the book of Theory of Machines by R.S. Khurmi and S.S. Ratan. Thank you.